Hi friends, today we are going to be learning about graphing with our proportions. So, just to kind of recap some stuff that hopefully you learned last year, and if not, pause a lot, take notes, we're all good, right? So, we have this graph here. In the middle, we have this point, 0, 0, okay? That's right in the middle right here. That's called our origin. That's where we're starting everything from. When we are looking at these 4 different parts of our graph, these are called quadrants, okay? They are created when we have our x-axis right here crossing our y-axis. And they are always labeled with Roman numerals. Do you see these right here? This is like 1, 2, 3, and 4, okay? We don't just ever label them with numbers, it's always Roman numerals for this part. Then we have ordered pairs. An ordered pair gives us a specific location on our coordinate grid. And they are always labeled in this way. We list our x value and then our y value. For example, if I wanted to pick this point right here, I went over 1, 2, 3, 4, 5, 6 to the right, which means I'm going to have a positive 6. And then I went up 2, so I'm going to have a positive 2. And that would be my ordered pair for that location. Now, if we move to the right, we are becoming more positive. If we move to the left, we're moving more negative, just like we did with our number lines. Then, if we're moving up, again, it's positive, and if we're moving down, it's negative. So, if I had a coordinate point that was right here, I would go left 2, which would be a negative 2 for my x value. And then I went down 3, which would be a negative 3 for my y value, and that's how I would label that. Now, we're going to come back to our favorite example, roses and sunflowers. With these proportions, we want to complete our table and be able to put these on a graph to see if they are proportional. So, we have 6 roses to every 2 sunflowers. If we have 0 sunflowers, we're obviously not going to have any roses either. And then we're trying to see what is our unit rate right here. When we have 1 sunflower, how many roses do we have? Well, we need to look at a part of our table where we know both data points. Remember, this is our x and this is our y. Right here we have 2 and 6. 2 times something is going to give me 6. That something is 2 times 3. So for every other part of this table, we need to multiply the x value by 3 to get this y value. So 1 times 3 is 3, 3 times 3 is 9, 4 times 3 is 12, and something times 3 is 15. So if we think about that, some of you might know that off the top of your head, or if you want to go back the other way from y to x, you would just divide by 3, and either way, that would give us 5. Now, we want to graph these points from our table. If you notice, we have the number of sunflowers, that is our x part, okay? This is going straight across the bottom, number of sunflowers. Those are our x values. The number of roses is our y, so those are going to come straight up. So the way that we work this is I have 0x and 0y. That means my point is going to be right here at the origin. Then I have 1, 3. My coordinate point would look like this. And I would go to the right 1 and up 3. My next point is 2, 6. So I would go to the right 2 and up 6. My next point is 3, 9. So I'm going to go to the right 3, up 9. And my final point to the right 4, up 12. If you notice, we can create a line through all of these points. So we can see that they have that relationship between them. They're proportional. Now this is the same graph we just had. It's labeled and we have our table still. We want to know, what does the point 4, 12 represent in the situation? So if we look, 4, 12 is right here. That means we have 4 sunflowers compared to 12 roses. The next part says to write the ordered pair that represents 9 roses and 3 sunflowers. So some of you may think, oh, we're just writing an ordered pair, 9, 3, call it good, right? But we need to pay attention to what order we are looking at. We have roses, those are our y value. So in our coordinate point, our y value is the second part, and our x value is the first. So instead of being 9, 3, this needs to be 3, 9. That is how you would write that coordinate point, because even though this 9 roses is listed first, it's our y value, so we have to put it second in our coordinate pair. Which point represents a total of 8 flowers? Well, what we can do is we can look, if we have 0 sunflowers and 0 roses, that means I don't have any flowers. 1 sunflower and 3 roses gives me 4 flowers. 2 sunflowers and 6 roses gives me 8 flowers. So I need to go to the coordinate point that matches with that on the table. It's right here. And that point is 2, 6. Now I want to know, if I have 100 sunflowers, how many roses should I have to keep the same ratio? Well, I know that I am just multiplying by 3 in every step. So if I made a new step where I have 100 sunflowers, I would still need to multiply by 3. 100 times 3 gives me 300. So if I want to keep the same ratio and I have 100 sunflowers, I need 300 roses. Now, if Shelley made a bouquet with 8 roses and 4 sunflowers, we want to know, is Shelley's bouquet the same ratio? So, 8 roses, again, that is our y value. 4 sunflowers is our x value. So we can come up with a coordinate point here. We have 4, 8. And now let's graph it. Let's see, is this proportional? So if we go to the right 4 for our x value, and then up 8 for our y value, is this point proportional to what we have? Well, it's not, because it isn't even in the same line as all of these other ones. We already have a point where if we have 4 sunflowers, we know that we need 12 roses, so that is not going to be of the same ratio. So, in our proportional relationships, our unit rate is showing our y value corresponding to 1 unit of x. So, That's like saying we have an increase in y as x increases by 1 unit. We have something y per x. That's how our unit rate is set up. When we are looking at a graph, we can use the point 1 comma r, where r is our unit rate. That means we go to the right 1 and up r, whatever r is equal to. We can also use x or y divided by x in order to find our unit rate, because in that proportional ratio, y divided by x is constant. That's another way of being able to figure out the constant of proportionality. So now we want to do this example problem. We have $2 for 5 oranges. So let's put what we know on our table. We know the number of oranges and the cost is $2 when we have 5 oranges. Now we need to divide so that we can figure out our constant of proportionality, right? This is our x value and our y value. To figure out the constant of proportionality, we can do y divided by x. In this case, it would be $2 divided by 5. So, if you were to plug this into your calculator, this would give you 40 cents. That means that for 1 orange, it costs 40 cents. So now all we have to do to finish filling out this table is multiply each number by 40 cents. 2 times 40 cents would give me 80 cents. 3 times 40 cents gives me $1.20. 4 times 40 cents gives me $1.60. Now, we want to graph these points. But this is a case where we're not just going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for our graph. We need to label it and see what our units need to be so that we can properly graph all of the points that we need. So, our x values are the oranges, and our y value is the cost in dollars. Okay? So, if you notice, the number of oranges, that's going up by 1. So I can just label 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, our cost is 40 cents. So we could technically do $1, but then we would get weird in-between ones that would be an estimation of where they're at, and we don't really want to do that. We could do it all by 20 cents, but then as soon as we do it by 20 cents, our top would be $2, and that only goes up to 5 oranges. We have way more than 5 oranges as a possibility down here, okay? Another thing, if you're looking ahead, is we want to figure out what happens if we buy 8 oranges. So we need more than 5. So the best way to do this is labeling it by 40 cents for each line right here. So we're going to have 40 cents, 80 cents, $1.20, $1.60, $2, $2.40, $2.80, $3.20. Wait. $3.60 and $4. So now we can graph these points. If I have 1 orange, I'm going to go to the right 1, and then it costs 40 cents, so I'm going to go up 40 cents. 2 and 80 cents, 3 and $1.20, 4 and $1.60, 5 and $2. Those are all of my points on this graph. So, what is the unit rate? We want to show this on the table and on the graph. So if we look right here, we have this graph, and the unit rate, if you remember, is going to be 1, R. So if I look over 1, up is 40 cents. That's our unit rate is 40 cents per orange. The places that we see that on our graph is right here, and on our table is this unit rate right here. Now, if we buy 8 oranges, how much do we actually spend? So, we can add 8 to our table right here. 8 times 40 cents gives us $3.20. So on our graph, we would go over 8, up $3.20. And that means that if we bought 8 oranges, we would spend $3.20 total. Finally, in this case, we just have a graph, and we need to fill in our table from here. So, if we look, this says the ratio of flour to sugar, and then we have cups of sugar and cups of flour. Well, the thing that we need to remember is this first part in our table is the X value, and the second value in our table is going to be the Y value. Okay? That means sugar is going to be our x-axis, flour is going to be our y-axis. So, looking at this first point, our sugar amount, our x-axis, is 2 cups, and our flour amount, which is our y-axis, is 5 cups. The next point is right here. We have 4 cups of sugar to 10 cups of flour. The next point is 6 cups of sugar to 15 cups of flour, 8 cups of sugar to 20 cups of flour, and this final point is 10 cups of sugar to 25 cups of flour. Question A says, what does the point 615 represent in this situation? So, if we go over 6 and up 15, this is one of our points. That means that I have 6 cups of sugar right here and 15 cups of flour. For this recipe, if I used 1 cup of sugar, how many cups of flour should I use? Well, this is like finding our unit rate. So, if we started out with 2, to get from 2 to 1, I can just divide by 2. And then whatever I do to one side, I have to do to the other side. 5 divided by 2 is 2.5. Which means that I would have 2.5 cups of flour for every 1 cup of sugar, and it wants us to write our answer as an ordered pair. So I'm going to take my x value, which is 1, and my y value, which is 2.5, and that is my ordered pair. It wants us to put a star on the approximate location of the graph. So if you notice down here, we don't have 1 labeled. we just have 2, 4, 6, 8, 10. So if we look, 1 is going to be about halfway between 0 and 2. If we follow this up, that is about where we would be at. So, just remembering, double check your x and y values, make sure your table and your graph match up, and make